Bapak, Ibu, ladies and gentlemen, we will start the workshop in a minute. Honorable Mr. Yuhuuu Dwinanda Priyadi, Chair of the Energy Transition Working Group, Mr. Tutuka Aryaji, Director General of Oil and Gas, Mr. Jun Arima, Senior Policy Fellow of Economic Research Institute for ASEAN and East Asia Area, Ms. Kikuko Sinchi, Manager and Senior Researcher of Mitsubishi Research Institute, Mr. Koji Hajiyama, Chief Operating Officer of Area, representative of G20 member countries, representative of invited international organization, representative of related ministry, regional government, embassy of friend countries in Indonesia, academics, oil companies, and related stakeholders. Good afternoon from Jakarta. Welcome to today's G20 side event workshop, taking the theme, Making CCUS Affordable, Enabling CCUS Deployment in G20 and Beyond. Give a round of applause to everyone joining us today. We have almost everyone with time difference today. Bapak Ibu, this is amazing thing of having the digital era. We may be met virtually, but I'm sure that we share the same spirit today. So thank you very much for joining us today, especially for panelists coming from Europe and US. Thank you. Ladies and gentlemen, the Direktorat Jenderal of Oil and Gas under the Ministry of Energy and Mineral Resources of Indonesia, in collaboration with AREA, warmly welcome everyone joining us today at the workshop that will take us all to discuss the CCUS, especially in its affordability aspect. As we can see, that CCUS is one of the crucial elements within the energy transition. And Indonesia, taking the opportunity of its G20 chairmanship, is inviting everyone to contribute on the deployment of CCUS. It's been an honor to have the keynote speakers today, the moderators, and also panelists that will share us their view. So without further ado, let's start the workshop. In the first of our agenda, we would like to warmly invite Chairman of G20 Energy Transition Working Group to deliver the welcome address. To Mr. Yuhuuu Dwinanda Priyadi, the time is yours.
All distinguished speakers and participants, good afternoon from Jakarta. I am Yuhuuu Dwinanda Priyadi, as a chair of the Energy Transition Working Group, ETWG, is pleased to welcome you all in the second webinar of the ETWG webinar series. The webinar has a desirable and strong tagline, which is Making CCUS Affordable, Enabling CCUS Deployment in G20 and Beyond. Affordability is the main challenge to deploy carbon capture technologies. G20 Indonesian Presidency chooses the main theme of Recover Together, Recover Stronger. The Presidency has set three pillars, namely Global Health Architecture, Digital Economic Transformation, and Sustainable Energy Transition. The pillar of Sustainable Energy Transition is held under ETWG, addressing three priorities on accessibility, technology, and financing. We have done the first meeting of ETWG 2 weeks ago in Yogyakarta. In that meeting, G20 members and invitees unanimously endorsed the three priorities in energy transition and the main agenda, heading towards the ministerial meeting and leader summit in Bali. We call all this stage as the road to Bali. Realizing the road to Bali, between the meeting of ETWG, we will deepen issues of energy transition to the series of virtual webinars. Today's webinars on CCUS will continue the energy transition journey throughout the presidency's year. To the Economic Research Institute of ASEAN and the East Asia area, I would like to convey our Presidency's highest appreciation and gratitude for taking the strategic role as co-organizer of this webinar. Through its Energy Research Institute Network, or ERIN, area together with Institute of Energy Economics Japan, IEEG, has been engaging key stakeholders not only from research institute in 16 Asia Pacific countries, but also from policymakers and multinational cooperation on supporting low-emission energy technology development. Through their preliminary joint studies, AREA and IEEJ have been simulating the scenario towards carbon neutrality within the components of renewables, nuclear, and CCUS. Then we could at least respond the following main question: why CCUS matters in clean energy transitions? Flashing back to COP26 Glasgow and several previous international conferences on climate and energy transitions, leaders around the world have mentioned carbon capture storage, carbon capture utilization and storage as one of the key solutions to reduce carbon emission and transform towards more sustainable energy system. To achieve an target of Paris Agreement, the international community will require massive program on reducing global CO2 emission from 40 million tons to 5.6 billion tons within next 30 years, which will be coming from CCUS on iron and steel industries, chemicals, refineries, and of course power plants. From an example in regional scope, the ambitious CCUS scenario in ASEAN will need massive investment for $1 billion per annum by 2030. In the business and market, carbon capture will become the key solution for energy companies, particularly oil and gas companies, to step forward towards low carbon businesses. Carbon capture won't become the only solution in dealing with emission reduction. There are several key initiatives such as greener transport for LNG. From a wider perspective, for instance, from circular carbon economy, CCE, recycle activities, particularly as the reuse will generate economic significance of carbon capture projects, particularly on concrete industries for building construction. However, reducing emission in high energy intensity economic sectors and removing CO2 to balance emission face huge challenge. The main challenge is to make CCUS more affordable. The cost to capture CO2 will contribute to the greatest portion for around 70 to 75% of CCUS total cost. This will vary depending on the local geographical structure, proximity with industrial area, and regulatory support on CCUS pilot projects. Other aspects also critical. In the commercial projection or estimation, in the applied technologies and pertaining infrastructure of CCUS development for industries. In policy and regulatory aspect, policies and regulation in global, regional, and national levels should be matched in order to enable carbon market and carbon pricing, which are supportive to CCUS development. In business model, more innovative business scheme could be arranged to make CCUS projects viable and applicable. To raise the affordability of this climate solution, we need to incorporate the price of CCUS into production costs while improving solid regulation in oil and gas sectors and also in carbon dioxide venting. If we could do those measures, at least we would enable oil and gas sector and also power sector to run CCUS projects with commercial basis. Therefore, this webinar aims to advance the discussion on recommendation, practices, and experiences on advancing CCUS. The key points are expected to become the powerful stopgap for strengthening the key deliverables of G20 ETWG, such as an action plan or policy recommendation. The key points will cover the deliberation of several key issues: continuous development of human resource capacity, and sharing of best practices for CCUS will cover technologies, regulatory, financing, business models, and necessary policy framework to support CCUS development and deployment. Research and innovation on CCUS technologies are absolutely required to reduce total cost within the whole value chain of CO2 capture, transportation, and storage. CCUS deployment targets for 2030 for projects with substantial support from government, public, and private sector could become the initial ambitious step, while exploring lucrative potential from climate financing. Full commercialization of CCUS from 2030 aftermath will be further developed with the consideration of each country's context. Without further ado, to the area, all key speakers from the global, regional, and national entities, Troika, as well as all G20 members and invitees, and broader stakeholders, I wish you all have a successful webinar. Thank you.
Thank you very much, Mr. Chair. Terima kasih, Bapak. Next, we would like to invite Mr. Tutuka Aryaji, Director General of Oil and Gas, to deliver the keynote speech. Please, Bapak.
Distinguished speakers, moderators, panelists, attendees, ladies and gentlemen, a very good afternoon to you all. It is a great pleasure for me to take part in today's G20 side event series, Making CCUS Affordable, Enabling CCUS Deployment in G20 and Beyond. Ladies and gentlemen, net zero emission has become an important target to stay in line with the Paris Agreement's goal. All G20 members have set the NZE targets, including Indonesia in year 2060. To achieve net zero emission, the development of CCUS technologies will be very important for Indonesia. Based on the IEA's roadmap for the global energy sector, the roles of CCUS technologies will contribute more than 10% of cumulative emission reduction globally to year 2050. In Southeast Asia, also based on IEA publication, to remain in line with the temperature objectives set out in the Paris Agreement, CO2 capture for CCUS in Southeast Asia will have to reach at least 35 million tons CO2 in year 2030 and more than 200 million tons by 2050. Ladies and gentlemen, in the G20 members, we can see that the development of CCUS is one of the emission reduction strategies for almost all members. Some members already have policies and large-scale projects. Some members are still in the demonstration projects, and the rest are still in the initiation stage. For Indonesia, CCUS has also essential roles in supporting Indonesian emission reduction targets. Developing oil and gas fields with high CO2 content and at the same time could also improve oil and gas production through CO2 EOR EGR. The utilization of oil and gas is still important because petroleum is the current main energy source for the transportation sector, and natural gas will also play important roles in energy transition before reaching 100% power generation from renewable energy. Ladies and gentlemen, Based on several studies, especially conducted by R&D Center for Oil and Gas, Migas, in depleted oil and gas reservoirs, Indonesia has a storage potential of around 2 gigatons of CO2, which is spread in several areas in Sumatra, Jawa, Kalimantan, and Papua. And the potential of saline aquifer is about 10 gigatons of CO2 from the South Sumatra and West Java basins. Ladies and gentlemen, several ongoing project studies of preparation are being conducted, especially in Kuyy, Sukawati, and Tangguh, with total CO2 stored potential of around 41 million tons CO2. We also have other potential CCS projects, such as CCS to produce blue ammonia in Central Sulawesi, East Kalimantan CCS study of CCUS for coal to the ME, Arun CCS, Sakakembang CCS or CCUS, and Abadi CCS. All of them are still in study or preparation stage, but most are targeted to be on stream before year 2030. Ladies and gentlemen, to support CCS development in Indonesia, last year, Direktorat Jenderal of Oil and Gas established a team for drafting regulation regarding the implementation of CCS activities. This team consists of MEMR, Sahabat Migas, and PPMA, COE, CCS, ITP, and Migas, Indonesian Petroleum Association, and oil and gas contractors. Under discussion with the team, the scope of this regulation will focus on goal setting to regulate CCS or CCUS through CO2UR, EGR or ECBM in oil and gas block, including technical aspects for capturing, transportation, injection, storage, also monitoring, and MRV. We will not regulate the technical aspect in detail, will be site specific based on the reference, standard, and good engineering practices. Second, commerciality or business aspects, which basically will be based on production sharing contract for oil and gas block. Third, legal aspects, including CCS program as part of Plan of Development or POD, transfer of responsibility, and etc. The fourth, economic aspects, including potential third-party funding and incentives, potential carbon credit monetization, and also related to revenue from carbon credit in the production sharing contract. Last February, we already shared the draft to the government public-private institution, research centers and companies from Australia, South Korea, Japan, European countries, United States, and also Canada in order to obtain feedback and improvements to the draft that has been prepared. Currently, we are finalizing the draft within the legal team, and we have also proposed the CCS regulation as one of the priorities to be enacted this year. We know that we have multiple industrial CO2 sources, not only from oil and gas. The integration and cooperation for all sectors through CCS hub and clustering is needed to enhance the feasibility of CCS projects by using shared facilities and potentially reduce the cost. At this point, mapping the potential of depleted fields and saline aquifer and also developing CO2 transport infrastructure for CCS become very crucial. CCS hub and clustering could also open for collaboration with all stakeholders through regional CO2 management. The utilization of CO2 is not only for EOR/EGR, but also be used to produce methanol and could be integrated for the production of blue ammonia or blue hydrogen plus CCS. Ladies and gentlemen, finally, to ensure future affordability of CCUS deployment, appropriate supporting policies and investment are needed. I hope through this event, we will have very good and detailed discussion, and we are looking forward to gaining invaluable knowledge from all speakers and panelists, and how to make CCS affordable in G20 members and beyond. Government of Indonesia also realized that the development of CCS requires cooperation and collaboration with all parties. And we will always support all stakeholders that promote CCS technologies to be implemented in Indonesia. Sincerely yours, Direktorat Jenderal of Oil and Gas, Yuhuuu. Thank you very much.
Thank you, Bapak. Our next speaker is Mr. Jun Arima. He is a Senior Policy Fellow for Energy and Environment at the Economic Research Institute for ASEAN and East Asia. He is also an economist and professor in the Graduate School of Public Policy in the University of Tokyo. Previously, he served as energy advisor to the permanent delegation of Japan to the OECD, as well as head of the Country Studies Division of the International Energy Agency, and held several director and director general positions at the Ministry of Economy, Trade and Industry of Japan. Please welcome Mr. Jun Arima.
Thank you very much, and good afternoon, ladies and gentlemen. It is a great pleasure for me to make a short presentation as a scene setting. Now, the reference scenario of the most recent IEJ Institute of Energy Economics Japan outlook shows that global primary energy demand will continue to grow from now to 2050. And as you can see, Asian region in red will occupy the bulk of incremental energy demand in coming decades, and energy demand will continuously be dominated by fossil fuels. And under the reference scenario, dominance of the Asian region is the same in global power generation scenarios. And while renewable energy will increase its share, fossil fuel will occupy substantial share even in 2050. And as a strong contrast with other regions, Asian region will see very high CO2 emissions growth in accordance with robust economic growth. And as presented by keynote speech, COP26 adopted Glasgow Climate Pact, pursuing efforts to limit the global average temperature increase to 1.5 degrees Celsius above pre-industrial levels. Decision also urges countries to accelerate efforts towards the phase down of unabated coal power. And to achieve 2050 carbon neutrality, countries need to take all available measures, including efficiency, hydrogen, electrification, renewable, nuclear, and CCUS. Since fossil fuel will stay in Asian energy mix in coming decades, the role of CCUS will be absolutely crucial. CCUS needs to play a larger role after 2030 in particular. And according to the Global CCS Institute, the amount of CO2 captured using CCS needs to be expanded globally from 40 million ton per annum to 5.6 gigaton per annum by 2050 for achieving the objective of the Paris Agreement. And if we are to pursue 1.5 degrees Celsius target, then the amount needs to be further bigger, nearly 8 gigaton per annum by 2050. And ASEAN has abundant storage capacity as presented in keynote address. Deployment of CCS can provide the region reliable, clean, and low-carbon power supply and decarbonize its large oil and gas manufacturing sector. Due to vast differences in economic development and emissions profile among countries in the region, and also different approaches to the CCS, perhaps a regional hub could promote a regional collaboration and achieve economy of scale and further reduce cost. An area our organization is now conducting cost-optimal deployment scenarios of clean energy technologies for achieving carbon neutrality in the ASEAN region as a whole in 2060. And technologies there include solar PV, onshore and offshore wind, hydro, geothermal, biomass, nuclear, CCUS, hydrogen, ammonia, DAX, and BECCS with certain conditions. And in the power generation mix under 2060 carbon neutrality scenario, as you can see, renewable becomes the main source, accounting to 69% of the total power generation in 2060. And hydrogen and ammonia, including co-firing, will be a part of decarbonization. But looking at more time horizon manner, in the short and mid-term, efficient gas-fired power plants will curb CO2 emissions from fossil power generation. And in the longer term, in particular after 2030-40, CCUS and co-firing with ammonia or hydrogen and 100% ammonia and hydrogen will play a dominant role together with renewables. And ambitious CCUS deployment is required in the ASEAN region to make this happen. And this calls for massive investment, growing to an average of $1 billion per year by 2030. And with that in mind, Area and Japanese government launched the Asia CCUS network in June last year. Its purpose are, first, sharing of knowledge and experience, second, developing common rules and projects, and third, realizing storage network throughout Asia. And 4 workshops and capacity building program have been organized up to now. And we will certainly continue these efforts. At the same time, we need to overcome numerous challenges for broad deployment of CCUS technologies in the region. First, capturing CO2 cost remains the largest cost, so it definitely needs to be reduced. Second, regulatory framework along CCUS value chain needs to be accelerated to provide business confidence for CCUS investment. And all costs, including capturing, transport, and injection and storing costs, vary according to geology suitability and terrain and proximity of industrial clusters. So therefore, government supports in the form of tax credit may need to be assessed case by case. And government definitely need to support building up the CCUS demonstration project. And from the viewpoint of industry challenges, commercial and technological and infrastructure are the barrier of industrial scale of CCUS. So therefore, large investment in CCUS needs to be accelerated with the government supports. And for ensuring revenues for such investment, there needs to be a market for CCUS, such as carbon credit or carbon prices. And policies and regulations perspective, global and regional policies need to work at speed to get all the carbon market workable. And in this regard, the final agreement of the Article 6 mechanism under the Paris Agreement is very laudable. And products from carbon recycling will need to be marketable with government policies. And finally, to make business models workable, development of business model is very important for the deployment of CCUS at scale. Thus, leaders of the G20 will need to work and develop strategies to create a carbon credit market across key geographies. So I think it is something like the food for thought for forthcoming discussion in this forum. But finally, let me add one thing. We are now experiencing very significant geopolitical tension ongoing, and it will have a significant implication to energy security and climate change debate in our countries. And one thing is very much clear, countries are giving fresh look to the crucial role of fossil fuels for the economic security, at least now and in coming decades. For this very reason, the crucial role of CCUS will even be greater. So with that, I'll finish my presentation and looking forward to listening to a very much active debate in this forum. Thank you very much indeed for your attention.
Thank you, Professor. Allow us also to invite the next speaker, Ms. Kikuko Sinchi. She is a senior researcher, Climate Change Solution Group, Sustainability Division at the Mitsubishi Research Institute. She has supported CCUS project development in Asian countries through engaging in policy dialogue with government officials and exploring carbon market opportunities. She has also supported private companies in developing strategies for CCUS development. Please welcome Mr. Kikuko Sinchi.
Good afternoon, ladies and gentlemen, and I would first like to thank the organizers, the Ministry of Energy and Mineral Resources of Indonesia, and also AREA for inviting me to speak at this very valuable event. Okay, apologies. I'm now trying to forward my slide, but I'm afraid I don't have the option to do so.
I shall share your screen.
Okay, let me try this again. Okay, thank you very much. Okay, my presentation will cover a brief introduction to my team at Mitsubishi Research Institute, cost estimation study, which is the main topic of my presentation, and summary and conclusion. First of all, Mitsubishi Research Institute was founded in 1970. We are a leading think tank based in Tokyo with over 800 researchers and consultants engaged in advisory surveys in a wide range of social issues. Since 2019, MRI has assisted the work of AREA with promotion of CCUS in the Asian region, with particular focus on carrying out knowledge share and capacity building activities for Asia CCUS network. And as introduced by the MC, my topic of my discussion is about the cost of CCUS throughout the value chain. And the purpose of this study that we conducted was to help visualize the whole value chain of full-scale CCUS project, from capturing to storing the CO2 at its final destination. We carried this out as part of the commission project by AREA. And based on public source information, the case study provides preliminary financial analysis of the main technical segment of the full-scale CCS project. For our study, we selected a model region, and in doing so, we referred to Indonesia as one of the major energy producers in the region. And within Indonesia, we searched for a place with high concentration of CO2 emissions sources and high CO2 storage potential in relative proximity. We selected the island of Java, which has the highest share of power plants in Indonesia, resulting in high density of CO2 emitters. And Java also has multiple oil and gas fields that have high CO2 storage potential. For selection of CO2 sources, we looked at the major coal-fired power plants on the island of Java and estimated their annual emissions. We selected in particular the Blora Regency at the Central Java province for this study. It is a relatively well-examined area for the purpose of CO2 storage and has good accessibility to multiple CO2 sources. We also made certain assumptions for our study. As many countries in the region still rely on coal-fired power plants as a relatively cheap and secure energy source, we recognize that a realistic demand is in retrofitting the existing power plants with the carbon capture technology. We decided to take a medium-scale ultra-supercritical coal-fired power plant as a sample for our study, as the power plants in this category are likely to be the last ones to be shut down. And we applied chemical absorption using amine, which is currently the most commonly used technology in carbon capture, with a carbon capture rate of 90%. We also assumed that the captured CO2 will be transported to an injection well at the onshore depleted gas field through a 50-kilometer pipeline. This slide summarizes the assumptions we made. And for estimating the carbon capture cost, we heavily relied on the previous study done by the Research Institute of Innovative Technology, or for the Earth, or RITE for short, for their cost breakdown of a capturing site at a retrofitted coal-fired power plant. All costs mentioned here include annual expense ratio of 9% and repair costs of 3%. Costs derived by RITE were scaled up for a capture capacity of 2.87 megatons per year, which is the assumption we made for this study. And as you can see, the cost component with the highest share in CapEx is the cost for supporting boilers, and for OpEx, it is the labor, with fuel costs coming in second. Secondly, we made estimations on the transportation cost. And for transportation, it is important to note that the pipeline costs are highly variable depending on the type of terrain and the need for crossing the infrastructure, etc. Pipeline over wetlands can cost twice as much as pipeline over flat or dry land. We used a model developed by the U.S. National Energy Technology Laboratory's CO2 transportation cost model. The model arrives at 3 different outcomes depending on the methods used, and we chose the one using what's called the Parker's method as the site we selected for our study with hilly and densely vegetated forests signifies higher price, and Parker's method produced the higher price among the 3. And as you can see, the labor cost has the highest share among the cost components. It's not the materials or equipment, that, but the labor costs that comprise the biggest portion in transportation. For operating costs for transportation, pipeline has annual operating costs such as fuel for compressor stations, repair costs, SCADA and telecommunications, etc. And again, the operating costs are relatively project specific, and the exact exact OpEx cost is not uniquely defined in existing documents. In most cases, it is expressed in a certain percentage of capital costs. Nevertheless, we used the NETL's model to calculate the OPEX for our model case study, and as you can see, result shows that electricity costs for pumps comprise the biggest portion. This slide summarizes the estimation of CAPEX, OPEX for their breakdowns. And what we did not consider in the transportation cost estimation is the possibility of maritime shipping of CO2, as we believe this technology is still not fully developed. However, we did refer to a study done in Europe and made estimation of cost if we were to ship CO2 by over 1,500 kilometers of distance. And I have attached the result of this estimation in the reference in the annex, so you're welcome to have a look after my presentation. And for storage cost, the cost model we used take into account multiple stages. And one is site screening, the second is site selection and site characterization, and the third it's the permission process and construction. And the technologies and equipment involved in geological storage are relatively developed technologies and are already widely used in oil and gas industries. However, we also need to take into account that there's a significant range and variability of cost due to site-specific factors, especially if the injection site, depending on injection site and depending on the reservoir depth. We also referred to storage cost model developed by Wright based on analysis of multiple cost scenarios for different site specifications. We used the figures circled on red on this slide for our study. And this is a result of our estimation of a storage cost. We made assumption of the depth of sink as 2,000 meters, and drilling cost assumptions are also mentioned here. Number of wells is also mentioned here, and we estimate a total capex for wells as they about 140 million US dollars. This slide shows a summary of CAPEX and OPEX for storage, and as you can see, for CAPEX, well comprise the biggest portion of the costs. Lastly, we applied a plant cost index to adjust for price fluctuation over the years. And for summary, we arrived at the unit cost of CCUS over the entire value chain of value chain for approximately 63 US dollars per ton of CO2. And it is with deliberate intention that I have not put the total cost in the numerical figure because, as I have explained, the costs, especially in transportation and storage, are very variable with highly project-specific nature. It is to note that the IEA estimated the levelized cost of capturing CO2 in power generation in the range of 50 to 100 US dollars per ton. And the result of our study for capture is a little bit lower than the IEA's estimation. However, it is also to note that the various sources suggest that retrofitting is not always the cheapest option. A thorough on-site feasibility study with specific site information is needed to further ascertain these costs. Nevertheless, what our study has told us is that our numbers are generally in line with the other previous studies that suggest capture cost comprise the highest proportion of the CCUS cost. And in our study, it reaches as high as over 70%. And this is the area that is likely to be the target for further technology and business model innovation if we are to put further effort into driving down the cost. With this, I would like to end my presentation. Thank you very much for your attention. Terima kasih.
Thank you, Ms. Inchi, for the informative presentations. Ladies and gentlemen, today's workshop is divided into 2 panel discussions. And just a minor information for moderators and also panelists that after you are introduced, there will be a bumper slide for a couple of minutes. So you may start after you are spotlighted on the screen. And for the first panel, allow me to invite Dr. Han Fumin, Senior Energy Economist of AREA, to be the moderator of the first panel. Dr. Fumin, you may lead the session.
A very good afternoon. First of all, thank you so much, Ashish, for handling this session to me. And a very good afternoon and welcome to session 2, which focus on a very important issue that how to make the CCUS affordable. I think the about sensitive, I think already very good to set all the rest of the session 1 and 2 for a deep discussion on the how we going to work around CCUS in terms of scaling up as well as the technology innovation and also critical policies that can ensure that the CCUS can take this can have its market. And fortunately we try to have a model case and business case that can have the CCUS have its own market. First of all, I would like to run through introducing all the distinguished panelists, and then I will invite one by one to have insight for your insight in this session. First, we have Mrs. Samantha McCulloch. She is the head of CCUS unit from International Energy Agency. And then we will have also Mr. Yuhuuu Lipponen, the coordinator of the Clean Energy Ministerial CCUS initiative. And we're going to have a video record because he is going to speak from the US because the time different. Mrs. Emily Gruber-Das, she is the Deputy Assistant Secretary for Carbon Management, Department of Energy, United States. And we're going to have Ms. Guloren Turan, a General Manager at Advocacy Global CCUS Institute. Finally, we have Mr. Kembai Brun, the Communication and Government Relations Director from the Northern Lights CCUS projects. Without further ado, may I call on Ms. Samantha McCulloch for your presentation and your sharing insight, please.
Thank you very much, Dr. Han, and good afternoon, everyone. It's such a pleasure to be with you today and to share some perspectives from the International Energy Agency on the importance of CCUS in net zero goals. I'll ask the team to advance my slide, please. So just to put some context around the importance of CCUS. When we model the global energy system and look at a target of achieving net zero emissions by 2050, CCUS plays a very important and substantial role. So it grows from around 40 million tonnes or so of CO2 being captured today to more than 1.6 billion tonnes by 2030. And by 2050, more than 7.6 billion tonnes of CO2 is being captured. And this reflects the value of CCS across a number of aspects. It can be retrofitted to existing energy and industrial infrastructure. This is a particularly important attribute in Southeast Asia, where much of the existing fleet is actually relatively young and have been recent investments. CCUS can also be one of few solutions to reduce emissions in heavy industry. And so in this chart, you can see this growing role for CCUS in industry in the yellow bars. CCUS can also enable a rapid and cost-effective scale-up of low-carbon hydrogen, and also it's an important technology-based solution for carbon removal, which is an important part of this sort of net zero equation. Thank you. Since today we are talking about making CCUS affordable, I just wanted to touch on the costs of CCUS and recognise that there is no single cost for CCUS because we are talking about a range of applications, and the costs can range from around $15 to $25 a tonne of CO2 in applications that have high concentrations of CO2 in the stream, to hundreds of dollars if you go all the way up to a more dilute source of CO2, for example, if you're looking at capturing CO2 directly from the air. The point I would emphasise when we're talking about the costs of CCUS is that in some of the higher cost applications today, these are at early stages of commercialisation. So that's in power generation, in steel, cement, for example. And we do see a significant potential for cost reductions as we start to deploy these technologies globally. Thank you.
Thank you so much, Samantha.
Thanks. I can leave it there. So these are just some quick high-level priorities in terms of scaling up CCUS, and I'll look forward to discussing these policies in the panel session. So thank you so much, Dr. Han.
Thank you so much, Samantha, for very precise information on this CCUS cost and other components. I will come back to you later after other panelists will present their insight. Next, let me call on Mr. Juho Lipponen, the coordinator of Clean Energy Ministerial CCUS Initiative. Juho, the floor is yours, please.
Hello, and thank you very much, Fumin-san, for the introduction. Thank you also Indonesia and area for the invitation, and it's great that Indonesia keeps keeps the CCUS on the energy agenda. This is really vital, and thank you very much for that. I would like to make 5 brief points before a discussion. Firstly, it's important to note and specify that CCUS is technically an option that is ready for deployment. If anyone doubts that, I think that that's not the issue. So technologies, of course, have to improve, but there is no particular technical reason not to be able to deploy large-scale CCUS projects anywhere in the world. I think that's something that we need to recognize at start. Second point is around affordability, and actually very much repetition to what Samantha was just saying. There isn't one single cost to CCUS. There's a range of these costs, and in some cases they are lower in that below $30 range, and in some cases much higher. But I think the point there is that deploying CCUS is already now a relevant option for many processes. So affordability is a very relevant but also relative concept, if you like. Third point around technical development and cost reduction. Of course, CCUS cost must and will be driven down over the years, as with any new technology as it gets deployed. And there's a number of levers actually for such cost reductions. Firstly, we have replication, simply doing more of the plants that we currently have, which leads to increase in experience, leads to economies of scale, market pressures in the markets for equipment and so forth, and that will reduce the cost going forward. Secondly, we have a big chunk in system optimization, if you like, with strategic hubs, oversized infrastructures that allow for the reduction of the transport and storage costs per ton that are large upfront investments. And thirdly, of course, we have technical development, technological breakthroughs and innovation that we have to work on, especially in the area of capture, that can allow a step change in technology cost reduction. But the point here is that we cannot only rely on technical research. I think deployment and replication is important, and we need to start doing this, and in doing so get the cost reductions ongoing. The fourth point is that clearly governments hold a very key role in kickstarting CCUS sectors in their jurisdictions. I think there should be practical discussions with key stakeholders in each country on where CO2 can be stored to start with. Secondly, where key emission sources can be combined into strategic hubs and how that can be advanced. And thirdly, the type of regulatory policy and incentive policy support that is needed to ensure that we can do this safely and that we can have incentives to drive CCUS projects forward. And fifth point, international cooperation is vital. G20, SEM, but also the groups with us today, IEA Greenhouse Gas Program, GCCSI, and others, are really there to help countries and industries to learn from past experience. And we can gain from the good practice, and we can avoid earlier mistakes. I would leave it at that. Thank you, and look forward to the discussion.
Thank you so much, Juho-san. You have put a very nice key message forward for our discussion. I will come back to you. Keep in mind that the variety of costs associated with the CO2 capturing costs, and I will come back to you specifically on that point as well. Thank you, Juho-san. Next, may I call on the next speaker, Ms. Emily Gruber-Das, the Deputy Assistant Secretary for Carbon Management, Department of Energy, United States. The floor is yours, please.
Hello, my name is Emily Grubert. I'm the Deputy Assistant Secretary for Carbon Management in the U.S. Department of Energy's Office of Fossil Energy and Carbon Management. It's a delight to join you today, albeit virtually, and I appreciate you making time for me to join you with this pre-recorded message to talk a little bit about cleaner energy systems and just transition, specifically as it relates to our efforts in carbon management, including carbon capture and storage and carbon dioxide removal. The Office of Carbon Management in the United States is deeply committed to facilitating decarbonization using carbon management technologies like mitigative carbon capture and storage and carbon dioxide removal pathways, including technologies and pathways such as direct air capture with durable storage, biomass with carbon removal and storage, mineralization, and many others. Our fundamental mission in the Office of Carbon Management is to evaluate technologies that may have a role to play in deep decarbonization that is so critical to meeting our global climate goals. Specifically, within the United States, we are driving toward full decarbonization of the electricity sector by 2035 and full decarbonization of the economy, net zero emissions, by 2050. In that goal, we also have an interim goal of reaching 50% reductions in greenhouse gas emissions economy-wide by 2030, which is coming up very, very quickly. As we think about our role in evaluating carbon management technologies, we recognize how important it is to really understand how well these technologies might be able to help us reach these goals. And specifically, what we need to understand about costs and their ability to perform to the standards that we know we need to hit, both technologically and from a social and justice perspective. We are extremely committed to evaluating technologies in a way that really tries to understand how they fit into society if they were to be deployed widely. And a big part of that is understanding at what level these technologies may be able to help really drive us toward deep decarbonization. As such, when we think about mitigative carbon capture and storage, one of the really high priorities that we have within the United States and within the Office of Carbon Management specifically is trying to show what the costs might look like and what the technological capabilities are of getting to nearly full decarbonization for power plants and industrial facilities, all while showing that we can do this in a just and equitable way. These efforts are deeply integrated with a lot of the work that we're doing globally and domestically, including with the Net Zero World Initiative, which really tries to think about how we truly get to a cleaner energy future by deploying energy technologies and other technologies that will help us to drive toward those decarbonization goals. Clearly, costs are a big issue, and one of our real goals here is trying to make it transparent what it actually costs to do these deep decarbonization carbon management technologies. That really looks like moving beyond some of the work that we've been doing for the past several decades on carbon capture and storage in the power sector that doesn't get as high of decarbonization as we might expect now, and trying to push these technologies to see whether we can deliver the types of decarbonization goals that we have. Similarly, as we think about the future, what we understand is that to get to a net zero world, that likely is going to include some level of carbon dioxide removal. When we think about carbon dioxide removal, we see this as a key technology area and a key activity that will really be very important to understanding what decarbonization pathways look like globally. As such, because it's such a critical area and also because it's such a critically new area, we recognize that in addition to evaluating costs, technologies, and how systems actually fit into the communities where they are, we really need to understand a lot of the justice implications of developing a new industry that could potentially be very large. This looks not just like thinking about some of the historical issues that we've considered, so many of the very critical environmental justice considerations, like what the impact of technologies might be on fence line communities, but also really trying to be very conscious of many of the institutional and governance and ownership structures that we see emerging with respect to carbon dioxide removal. We have an enormous opportunity to do this very, very well, and it's a huge responsibility area that we see of evaluating the technology, not just for its capabilities, but also for how we really deploy it and how we see it developing both in the United States and globally. As such, one of our really significant efforts is called the Carbon Negative Shot. This is one of the energy earth shots that the U.S. Department of Energy is invested in and is an all-hands-on-deck call to try to really understand what carbon dioxide removal could look like. Over the next 10 years, we anticipate trying to demonstrate that we can reach $100 per net metric ton of CO2 equivalent removal for carbon dioxide removal. This is an ambitious, ambitious goal, and it's one that must be backed by really significantly rigorous life cycle assessment, understanding of what the various costs might look like, including monitoring, reporting, and verification, and really trying to understand what the conditions that will allow these technologies to scale might be. We know that carbon dioxide removal is expensive today, but we believe that by really focusing on sustainability and justice and really trying to understand where these technologies and pathways could fit into future decarbonization, we have a large role to play in overall decarbonization. Thank you again for having me today, and I look forward to hearing more about this meeting, and I apologize for not being able to join live. Thank you.
Thank you so much, Ms. Emily Grubert, for sending in a very important pre-record video that she sent in very key message in terms of how the policy going to support the technology innovation to cut down costs, as well as seek the possibility how this is going to come into a big play in deep cut of the emission in the next 10 years and forward to the mid-21st century. I think the next speaker, may I call on Ms. Guloren Turan, the General Manager, Advocacy, Global CCUS Institute. The floor is yours, please.
Dr. Thumen, and thank you to the Ministry of Energy and Mineral Resources of Indonesia and also AREA for inviting me to participate in this very important event. I had a few slides. I don't know if they're going to be available or not. Just wait for a moment. I'll get started, and following from the very insightful comments from our previous speakers, I'd like to emphasize that carbon capture and storage as a key climate solution has been gaining momentum around the world in the past 4 years, driven by net zero commitments by countries and by companies. This has driven the necessity to deploy CCS, creating a virtuous cycle whereby governments have reacted by strengthening their policies and private sector is gearing up its investment in CCS. In 2021, we as the Global CCS Institute added some 71 new commercial CCS facilities in our database of facilities that are in operation and under development, thereby increasing the global facility capacity by almost a third to 135 facilities, 27 of these in operation, and the remainder of these facilities are in development. In 2021, we also witnessed a number of new countries announce commercial scale CCS projects starting development. Of course, these include Malaysia and Indonesia and Malaysia in the Southeast Asia region, in gas processing and facilities in gas processing and in ammonia production. We've also seen the first commercial applications of CCS being developed in liquefied natural gas, in direct air capture, and of course the first commercial scale cement facility with CCS is starting construction in Europe. Next slide, please. One of the key drivers of growth has been as referred to as by our previous speakers, the importance of the business model, the costs and economics. And one of the key drivers of growth has been the emergence of networks, CCS networks, otherwise sometimes referred to as hub and cluster business models. Early developments of CCS adopted a point-to-point model where a single large emission source was connected to by a dedicated pipeline to a sort of a unique storage site. However, like most industries, CCS benefits from economies of scale, and therefore hub and clusters are quickly emerging as the preferred business models. Networks, these involve connecting multiple emission sources by a common shared transportation pipeline or transportation infrastructure to a shared large-scale storage facility. Networks reduce both risk and through economies of scale, as Yuhuuu, the opponent, mentioned, they allow smaller facilities, smaller emission sources to be connected to a network, and they lead to reduced unit costs. What this means is that CCS can sustain local businesses and create further jobs and sustain local economies. We find that governments, communities, project sponsors, and they all like them. And currently there are some 30 CCS networks in development around the world. And we'll hear more from Mr. Kim Bai-Brun in a moment about one of the kind of key networks that are under development, the Northern Lights project. Next slide, please. Nevertheless, in order to meet our climate targets, the CCS capacity needs to grow by at least 100-fold in the next 30 years by the middle of the century. And at the Institute, we estimate that this will require around $1 trillion of capital investment over the next 3 decades. In order for this scaling up to happen, stronger policies to incentivize CCS deployment are needed, including putting a value on carbon emissions through carbon price or carbon tax, defining the role of CCS in national climate targets, for example, in the national determined contributions. And the governments, of course, can play a strong role in facilitating the development of CO2 transport and storage infrastructure, and they should and can clarify key legal and regulatory frameworks and issues. And with that, I'd like to thank you, and I look forward to the discussion.
Thank you so much, Golo Rensan. I think you put very important message for this discussion. I will come back to you, particularly on the industrial CO2 cluster and network that play, I think, probably a important business model later on. I will come back to you. By the way, thank you so much. And may I call on the last speakers, Mr. Kuyy Bruns. He is the Communication and Government Relation Director from the Northern Lights CCUS project. The floor is yours, please.
Thank you very much, Dr. Han, and good afternoon, everyone, and thank you very much for the invitation to participate at this event. I'm very pleased to join you today from Stavanger in Norway. Northern Lights is responsible for developing and operating CO2 transport and storage facilities open to third parties. And we're part of the Norwegian government's full-scale carbon capture and storage project, which has been named Longship. When we start operations in 2024, we will be the first ever cross-border open source CO2 transport and storage infrastructure network, shipping CO2 to an onshore receiving terminal on the Norwegian west coast before being transported by pipeline for permanent storage in a reservoir 2,600 meters below the seabed. Northern Lights is not a concept or a plan. It's actually happening. We are building the facilities as we speak. The first storage well has been drilled, and we will be drilling a second well this summer. The receiving terminal is under construction, and we have awarded contracts for building of 2 ships with the capacity of 7,500 cubic meters each, which means that they can carry 8,000 tons of CO2. Phase 1 of the development will be completed in mid-2024 with capacity of 1.5 million tons per year. And we are already looking at capacity expansion to 5 to 7 million tons per year. And we have ambitions to go beyond that in a third development phase towards 2030. The capacity and range for any additional ships we may build will also go up, and we will likely need another 9 ships in the second phase. What we offer is an open storage concept, which is breaking the link between source and sink by use of CO2 shipping. That means that we are not tied to one capture site, but can store CO2 from any source within reach for our ships. It is important to keep in mind that right now there is a first mover disadvantage. We know that CCS is key to achieve a just transition. We will need around 600 million tons of CO2 stored every year by 2050 in Europe alone. And to speed up the development, we therefore need help from policymakers, as well as industry and interest organizations. And what we need is business models. We need national support mechanisms. We need higher CO2 price, willingness to invest, regulation, standardization, and operational procedures for certification and metering. CCS is hard, but so is everything else. We have to make it a success. So thank you for your attention, and I'm looking forward to the discussion.
Thank you so much, Kim, for very important message, practically from the current Northern Light CCUS project. I think we're going to have a lot of discussion with you, but keep in mind that I'm going to ask about something about key regulatory and commercial issue around how to make this project work. Probably you can touch on later on. But thank you all the distinguished panelists. Let me come back first to Samantha for her presentation. I just want to raise one question about why CCUS is the least cost abatement option, and is it competitive at the current cost, and why, if they are at the very, I think, various costs from these from very low cost of gas processing like ammonia to very high capturing costs like cement, steel, and power plant for CO2 source from those in heavy industry. So if the current cost, first, is it competitive, and why it becomes the least cost abatement cost for that heavy industry? The floor is you, Samantha, please.
Thank you, Dr. Han. I think, you know, we've had a consistent message this afternoon that there's no one cost, and it really depends on a number of factors, and most particularly which application you're looking at. I think if we can focus particularly on heavy industry applications for CCUS, so steel and chemicals and cement, for example, we really see that CCUS is one of the most mature and most competitive options to really reduce emissions down to close to zero. And there's a few reasons for this. One is the fact that there's a lot of existing infrastructure, so the retrofit potential for CCUS is important here. Also, many of these processes rely on very high temperature heat, where there are limited other technology solutions. And finally, I would just emphasize the role of CCUS in addressing what we call process emissions. So if I can take the cement sector, for example, cement accounts for around 7% of global CO2 emissions. So it's a significant contributor to greenhouse gas. And yet 2/3 of the emissions from cement are not related to using fossil fuels, for example. They're process emissions that are chemical reactions. And today, the best option for addressing those emissions is to physically capture those emissions and store them. So this is why we're seeing CCUS emerging as a very sort of cost competitive and important technology in these sectors.
Thank you so much, Samantha, for very excellent elaborating on this point. I really appreciate this, and I hope everyone also appreciate your answer on this important question about these. CCUS is one of the least cost abatement option for the heavy industry. Thank you for that. And back to Yuhuuu-san, may I also raise one question about your presentation? Given a wide range, as I said with Samantha, of CO2 capturing costs, range from $30 per ton of CO2 in the gas processing like ammonia and other, to over 100, particularly for the coal power plant, steel or cement industry. And in your view, how you see that the government can able to be more specific about the incentive? If we are giving just one incentive across the industry, actually there are various costs of the CO2 capturing costs. So in your view, how the government can provide a different option and incentive for different industry?
Thank you, Poomin. That's a good question, and I think it's a very relevant one, because indeed you have such a range of different costs, so they will all require a different type of incentive. I think the incentive policies that countries have in place or the countries are putting in place, they vary. Some of them are somewhat more sort of, should we say, uniform, such as tax credit systems. The US, the one Canada is putting in place, where you basically have one rate. Excuse me, I have a phone ringing here. Excuse me for that. So some of them are more uniform and basically have one level, depending a little bit on how you store the CO2. But there are examples of more diversified ones. For example, if you look at systems that, for example, in the Netherlands or in the UK are being discussed and being put in place, implemented already, which have a mechanism whereby you define a price, or let's say the cost of your capture of CO2 per ton, and you compare that with the essentially carbon price, and government pays you a difference between the two, and that allows for more differentiation between different types of projects and different types of cost levels that there are in the CCS market, if you like. So it is possible to diversify, and maybe I would offer the Dutch or the UK systems as interesting examples in this regard.
Thank you so much, Yuhuuu. I think this is one of the very important point. If the ASEAN country in ASEAN and East Asia are going to seriously develop policies to support CCUS, I think this point they have to look at a different technology, different source of CO2 emission, and what particularly incentive need to be targeted based on the original cost of each of technology. Thank you, Yuhuuu, for this point. I really appreciate. And the next, to Ms. Gulorens, I have one question, particularly for your presentation. I think it's very outstanding in terms of how we're going to able to reduce cost and risk by having the share network or infrastructure. Another word is called industrial CO2 clusters. This would be one of the preferred business model that could drive down the cost as well as to reduce risk, and this can develop to be one of the very successful business case, I hope. In this case, could you share a little bit on the what are the regulation in place so far to make this share clusters or infrastructure workable?
Thank you, Dr. Froman. And so, for example, when we talk about CCS networks, I think a very, to me, a relevant example is the Summit network that's under development in the US, which comprises of some 30 plus ethanol facilities that will use the same transport and storage infrastructure. And this is a good example because ethanol, as we heard from Samantha, is one of the lower costs applications of CCS. It's ethanol facilities have a pretty concentrated CO2 stream, which is therefore it's lower cost to capture from $20 to $25 or $30 a ton. However, those are small facilities on their own, and so it's not economic to have, or it makes the economics much more challenging to have only one ethanol facility with a dedicated transport and storage site. So in this instance, actually having 30 plus facilities come together and using the same transport and storage makes the economics much more feasible. We heard from Kim Bar-Brun about the potential to scale up infrastructure. Again, another kind of example that is in operation is in Canada and in Alberta with the Alberta carbon trunk line, and what's needed for this, and what's happened actually in terms of getting this network up and running is public and private collaboration, where the government of Alberta facilitated and supported the development of its infrastructure, working with private companies The pipeline itself has a capacity to transport and store around 15 million tons of CO2, but currently there are only 2 facilities that capture and store around 1.5 million tons of CO2. So there's a lot more spare capacity, which wouldn't have been possible had the government and the private sector companies worked hand in hand to make this happen. In terms of regulatory challenges, particularly as we're looking at regional CCS networks that involve perhaps a number, not just within one country, but that involve a number of countries, which may well be, we hope, the case in Southeast Asia as well. It's important that London Protocol, which was seen as a barrier to border CO2 transportation. There has been an amendment, although it's not been ratified in 2019, a provisional application of the amendment has been agreed upon. So countries, I think, need to work hand in hand to ensure that this amendment is put into action so that CO2 can be transported between countries, between those countries that have sources of emissions and those countries perhaps that have more storage resources. So I think that's an important regulatory component that needs to be put in place, and perhaps Mr. Kim will talk a little bit more about it. But thank you.
Thank you so much, Guloren, to highlight very important of these infrastructures, of the shared infrastructure, and these leading to very important as well that these, as we need to have a regional hub of these CO2 storage, it's important to look at regulatory of how CO2 can be transported across the boundaries from one country to another. You highlight about London Protocol. I think this is critical for the application to ASEAN context for policymakers to look at later on. Thank you for your insight about this point. Next, I would like to call on Mr. Kuyy Brun. I have one question particularly to your presentation. As you know that this Northern Light is quite important, and it currently a real example for the CCUS CO2 capture, transport, and storage. Could you also share with us a key regulatory and commercial issue for the CO2 transport and storage at the Northern Light, if you may? And then what are these current incentives, if you can also share that? I know there's hard to strive for business model, but if you can share what actually the incentive currently the Northern Light receive to ensure this can have a good revenue stream, perhaps it will be important for our stakeholder. The floor is yours, please.
Thank you. Well, first I would like to say that the Northern Lights project is supported 80% by the Norwegian government. So we have a significant support in the development of our infrastructure. This is for phase 1. Phase 2 is going to be developed by funding from the owners. And it does not include the kind of capture side. If you look at the European customer base, there are 2 capture facilities in Norway that also are supported by the Norwegian government. But aside from that, the most significant legislation with an impact on CCS includes the EU Emission Trading System, ETS. Which is intended to drive investment in low carbon technologies. And right now, the cost of emitting a ton of CO2 is 78 euros per ton. That's as per today. It has been almost at 100 earlier this year, but only a year ago it was as low as between 20 and 30 euros. Now, this is the most significant kind of incentive for capture operators to, or for industrial emitters to actually capture their emissions. Now, for us, obviously, we need kind of a commercially sound business model. The business model doesn't really exist today. This is a new thing. It's a new market. And therefore, we see that the conversations we are having with industrial emitters in Europe today are complex and take time. But we are hopeful that we will soon be able to sign our first commercial contract, aside from the two kind of emitters which are part of the Norwegian Longship project, and that we will set the standard in terms of what these contracts look like. And there will be kind of aspects around liability there, along with a lot of other aspects that need to be covered.
Thank you so much, Kim, by putting very important message for today's discussion. We learned a lot from Northern Light. I think that how the government support the project, how commercially that will taking place later on. And most importantly, I think the carbon price in Europe is very good now, almost $100 per ton CO2. I think this is a very good incentive. And I think this highlights the importance of the emission trading system that I think Asian context is still far away. Hopefully we can learn more from the European case to ensure that the policy instruments, including these carbon price, carbon credit will be in place is one of the important things to support. Thank you, Kim, for your important message. I think we have reached the time, and let me take this opportunity to thank all these distinguished panelists that coming forward with very critical and important message for our session discussion around the how making CCUS affordable. This is important that the ASEAN stakeholder really want to understand about the CCUS cost and what need to be done and what policy need to be in place, what infrastructure investment, etc. This is quite important, and it will fit into the further discussion and a policy formulation later on. And I take this opportunity to thank you again for your time and your contribution to this session. And let everyone applaud and put hand for all the distinguished panelists. Thank you so much, by the way. And back to you, the Miss MC. Please, back to you.
Thank you, Dr. Fumin, and all the panelists. Give a round of applause for the moderators and the panelists, everyone. Thank you. Ladies and gentlemen, we are moving on to the next panel discussion, and joining us already, Dr. Saleh Abdur Rahman. He is the member of the Committee of the Downstream of Oil and Gas Regulatory Body of the Ministry of Energy and Mineral Resources of Indonesia. Bapak Saleh, you may lead the session.
Thank you, Ibu Sularsi. A very good afternoon and evening for all distinguished speakers. Yeah, thank you, Ibu Sularsi. A very good afternoon and evening for all distinguished speakers and participants from across the globe. We are now entering our session 2 of the program. As we know that developing countries has huge potential to deploy the CCUS to meet the NDC and net zero emission target. However, we face some challenges that we need to resolve, especially on regulatory, technical, and financial aspects. Our topic today is how developing countries, including Indonesia, could implement CCUS and resolve all the challenges. We have 4 distinguished speakers. First is Pak Tim Dixon. He is the General Manager of the IEA Greenhouse Gas. The second speakers, Professor Rahmat Sule and Dr. Usman Pasarai from Indonesia Center of Excellence. Our third speakers, Dr. Oki Muraza from Pertamina. And our last but not least speakers, Mr. Darshak Mehta, a senior CCUS specialist from ASEAN Development Bank. I would, without further ado, I would now like to invite Pak Tim, to share his views. Your time is 5 minutes, Pak Tim. Thank you. Please take your time.
Okay, thank you very much, Dr. Saleh. Can I just check that you can see my slides?
Yes, we can see your slide, Tim.
Okay, that's good. Thank you very much. And thank you very much to the organisers, to Evraya. It's a great honour to present here today, and especially because I think the G20 is so important in coordination in the world. I had the honour of being involved in the G8 when we got CCS initiatives first in the G8 in 2005, and then the G20 came along with its summits in 2008, and it's very pleasing to see that CCS continuing in these since that date. So I have 4 points to make today on 4 activities that developing countries could do or can do to implement CCUS in their own countries. Firstly, I just have to show the disclaimer slide to say that what I say does not reflect the IEA, but we were set up as a technology collaboration program by the IEA. I have more slides than I will speak to. They are here for reference afterwards. We've heard about the NDCs and the need to update these later this year. That's very important. You've heard about the applications of CCS to any large point source of CO2, and the technologies are ready to deploy. We have storage security because we put it very deep beneath the ground. This is to scale on a coal power plant in Canada. And let me start with these 4 activities that developing countries can do to implement CCUS. The first is to understand their national potential. That is, firstly, identifying their large point sources of CO2. They will have this information through their greenhouse gas inventories. The second is to assess their geological storage potential. Now, the type of geology that we use is in sedimentary basins with reservoir seal pairs. This is very common around the world, but it's not evenly distributed. There's more than enough for all of the CO2 storage we may ever want, but it may not be in every single country. So to understand the geology where it is in a country is very important. It will involve the geological surveys of the country, and to assist in the early stages, we have this report from IAGHG to start that process off. And the third part here is to assess the national regulations to apply to CCS or CCUS. And if a country has an oil and gas industry, that's very good because it means they're likely to have the right geology that stored CO2, but also they'll have regulations in place that may be relevant. And there are tools to assess national regulations. The Global CCS Institute has its regulatory toolkit, and the IEA has its CCUS handbook on legal and regulatory frameworks due to be published this year. And in addition, on regulations, and I think I saw some questions in the chat, there are international regulations already in place to assure the safety and security of CO2 geological storage. We have them from the UNFCCC for CCS and the CDM. We have them for offshore storage in the London Protocol. We have international standards from the ISO, as well as countries' own. And it's very pleasing to hear that Indonesia is in an advanced stage in its own regulations for CCS. The second activity is capacity building. This is raising awareness in a country with stakeholders. That's very important. The photograph here is from a recent workshop in Trinidad and Tobago that we were involved in. If you have an oil and gas industry, retraining the professionals, they've already got the right skill sets. So it's a modest retraining needed, but also training and educating students. And as IAGHG, we run the main international CCS summer school. And in 2020, we really wanted to bring it to Indonesia, hosted by ITB in Bandung. But of course, COVID came along, and I apologize for my voice today. I have COVID. We are still hoping to bring the summer school to Indonesia in this year, in December. But in the meantime, with ITB, we've done the virtual summer schools instead. And the third part here in the capacity building is join international organisations such as ourselves, such as the Global CCS Institute, such as the SEM CCUS initiative, and the CSLF as well. The third activity is establish a centre of excellence, and we're going to be hearing about the Indonesian centre after me. This is really important because it creates a national resource of expertise. It can help inform governments on their updated NDCs, and it can lead on all the other activities that need to be undertaken as well. And there's good examples in here in Indonesia, in South Africa, and China, and elsewhere. And the fourth activity is share the experiences with other developing countries and learn from other developing countries. This South-South cooperation as a term for this, I think, is very important. We can do this through the Asia CCUS network, as we heard earlier. ADB have their annual energy forum, and also the UNFCCC COPs. And this term, South-South cooperation, actually came about, its use started in Indonesia in 1955 with the Bandung Africa-Asia conference. So it's very good to be using it here today. And there were good, many of these that take place. Just one example is a side event that we organised with the University of Texas at COP26, where we had Indonesia, Dr. Rahmat Suli, who's presenting next, and Professor Rafi Hussain from Trinidad and Tobago, both countries that are more advanced in developing CCUS, to share their experiences and their learnings with Nigeria and with India and with the others in the audience as well. So please share your experiences and learn from others. So those are the four activities that I would like to suggest, and the rest of the slides are here for your reference on my organisation. So thank you very much, Dr. Saleh, and I look forward to the discussion afterwards.
Thank you, Tim, for your essential and substantive presentation and recommendation on how developing countries to implement CCUS. I will come back to you, Tim, after we finish with all the speakers. Thank you again. And now we would like to invite our two speakers from Indonesia, Professor Rahmat Sule. He is from the Center of Excellence of the ITB, Bandung Institute of Technology, and Dr. Usman Pasarai, from Oil and Gas Research Center in Jakarta. Your time is now. Please take your time, Pak Sule and Pak Usman. Thank you.
Okay, thank you very much, Pak Saleh, for the introduction, and I would like to thank also the committee area and also MEMR for giving us the opportunity to deliver about the role of the Center of Excellence for CCS and CCUS in supporting CCUS implementation in Indonesia. Next slide, please. Perhaps we would like to start with our reality. So based on Indonesian NDC, we target to reduce the greenhouse gas emission between 314 until 398 million ton of CO2. And then if we take several low-hanging fruit CCS and CCUS project in Indonesia, which is connected to the oil and gas industry, it seems that 137 million ton of CO2 could be reduced within 10 years. It is equal to about 34 until 44% of our target in reduction of emission. So that's why we would like to learn how CCS and CCUS will be implemented in Indonesia. And later, if the technology for separating the CO2 from the exhaust of coal-fired power plant is found, maybe the target for the reduction could be increased. So that's why CCS and CCUS can play an important role in Indonesia, since there are a lot of CO2 sources from the energy sector, and their location are close enough to depleted oil reservoir and coal mining. Next slide, please. This is several activities that are conducted in our center. So basically, we implement what Mr. Tim Dixon advised to us, and also some advice from our international partners. So basically, we spread our knowledge and awareness about the CCS and CCUS in some exhibition and also symposium. And on the same time, we conducting several studies, for example, about the preparation of the CCUS in Bundi field. Has been mentioned also by Mr. Tim Dixon that we work together in conducting capacity building program. Last year, we conduct international virtual courses and attended by 250 participants. And also, publication is quite important, and we are very happy to announce that we are quite productive in this matter. Next slide, please. And then another important activities is the cooperation in conducting studies and projects with industry and international partner. So here we have cooperation with CO2 producer from the ammonia plant, and also with Pertamina in determining the decarbonization study, and then mapping of the CO2 source and sink is also conducted by us. And in the last year, we have conducted also CCUS feasibility study at Tangguh Field, and hopefully within this year we could start a new study related with the CCUS feasibility study in Abadi and Saka Kemang Field. Next slide, please. And this February, we have finalized the draft of the regulation related to the regulation of the CCS and CCS implementation in Indonesia. And the aspect that are regulated is from subsurface until surface facility, and also how to conduct MMRV, and also the business opportunity that could be offered to the stakeholder. And we have also conducted several socialization to the international communities in Europe, Japan, Australia, Korea, and also US and Canada. That's all my explanation, and it will be continued by Pak Usman. Thank you very much.
You still unmuted, Pak.
Following Mr. Sule, I would like to add more activity that have been carried out by the center in order to deploy CCUS Indonesia in making this technology affordable in the context of Indonesia. So the initiative to establish a Center of Excellence of CCUS by Direktorat Jenderal of Oil and Gas, the Ministry of Energy and Mineral Resources, through supported by ADB Knowledge Partnership Program, is a key enabler in deploying CCUS Indonesia. Although that CCUS activities in Indonesia are involved across sectional ministry and agency, but the most suitable near-term development CCUS Indonesia, as Pak Sule explained before, will be in the oil and gas upstream sectors. These sectors offer low-cost solution for each state of CCUS, where supply from a natural gas processing plant, while depleted oil and gas was the storage. Utilization CO2 for enhanced oil recovery or enhanced gas recovery is the one technology being considered as a driver and early mover for developing CCUS in Indonesia. The importance of this technology as facilitator for CCUS particularly significant where there is no established financial or regulatory incentive for sequestration CO2 emission. CCUS in the form of CO2 AWR has been proven effective for increasing oil production substantially, while a consistent amount of CO2 injected stored permanently at the same time. A number of studies have already been carried out by the National Center of Excellence, as Pak Sule explained in his slide before, in cooperation with Pertamina and also supported by such as ADB, World Bank, METI, and other international institutions to assess the potential for CO2 AWR in Indonesia and to match source of CO2 with oil fields. The critical first step in the process of developing CCUS in terms of CO2 AWR in Indonesia is to launch an initial pilot project. The learning and experience from this such of a pilot project will be enormous value in helping operator design commercial project and helping policy makers draw up a robust business model, effective legal and regulatory framework for CCUS in the form of CO2. A pilot project at Sokowati oil field located in East Java, where production has been declined for several years, under evaluating by the Center of Excellence in cooperating with Pertamina, JAPEX, and supported by METI. In this pilot, if this pilot proves to be successful, a commercial scale project emphasizes involving the use of existing production well and drilling 9 new well injection wells. The SL2 needed for the pilot project will be sourced from the Sokowati field itself. This field currently produce associated sets with 40% CO2 content, and additional additional anthropogenic CO2 will be needed for the full field scale project. It will come from the nearby gas processing plant, and this field is capable storing around 14 billion tons of CO2 over assume project lifetime of 15 years, increasing oil recovery rate by around 40%. Thank you. That's all my addition. I highlight the role of CCUS, Center of Excellence. Thank you, Dr. Saleh.
Thank you very much, Pak Sule and Pak Usman, for your valuable information on the CCUS activity in Indonesia. I will come back to you after we finish with our next two speakers. Thank you, Pak Sule and Pak Usman. Now I would like to invite Dr. Oki Muraza from our state-owned oil and gas company Pertamina to present Pertamina's plan and activities on CCUS. Oki, your time is now. Please take your time.
Thank you very much, Pak Dr. Saleh. I hope that my voice is clear. Good afternoon, ladies and gentlemen. Thank you for area. Thank you. Thank you for area Asia CCUS network and Ministry of Energy, Mineral Resources of Republic Indonesia. And also thanks for the Energy Transition Working Group for the invitation. I'm Oki Muraza, the Senior Vice President at the Research and Technology in Pertamina Holding. This afternoon, I would like to highlight about the activities that we have in Pertamina Group. So yeah, as you can see on this slide, basically in Pertamina, first we try to unlock the potential of CCS and CCUS field. Pertamina continues to make effort in the screening and selecting fields that can be used as the injection sites, and also we collaborate with a lot of companies in feasibility studies and the first step in the implementation of CCUS projects. Thank you for Tim Dixon who just explained about the assessment guidance, and also thanks to Pak Rahmat Sule and Pak Usman who just explained about the pilot projects, Sukawati. So basically, we try to obtain first the technology in order to capture the CO2, and then we need to determine the CO2 emissions along the mapping, storage, and locations. Then we study different options for CO2 capture and purifications. After that, we locate the mapping and we calculate the CO2 storage capacity. We study the transportation options, mostly through pipelines. Tracking and shipping will be considered after 300 or 400 kilometers from the source. And then we also explore the potential mapping of interconnections in order to establish hub or clusters. And last but not least, we need to find the business scheme. Then the next step is basically the utilization option that we have. So we try to put priority on the utilization prior to the storage. We have different ways in order to utilize the CO2 as a feedstock, also as an input. The first one is basically we try to convert CO2 to precipitated calcium carbonate by utilizing local resources. At this moment, we are building the demonstration plants. And then the next one is the conversion of CO2 into polymeric product. At this moment, we are developing the conversion of CO2 into polyurethane. And then we have also initiatives to fix CO2 into microalgae by different strains of algae. And then we also develop the conversion of CO2 to low carbon, such as CO2 conversions to methanol, and also CO2 conversion to synthetic fuels. And then the fourth option is, of course, to utilize CO2 for enhanced oil recovery or enhanced gas recovery. And the last option is for the storage. Then the key takeaways from our developments, basically echoing from some suggestion from Global CCS Institute a few minutes ago, that we listen within these sessions. At this moment, we receive support from the government. Yeah, we have the research funding grants from Indonesia Endowment Fund for Education (LPDP) and also from Ministry of Education and Culture. We also receive support from Ministry of Finance in terms of super tax deductions for decarbonization research. In the future, we expect that there will be carbon economy value from Ministry of Environment and Forestry. We expect that there will be soon the regulation for the implementations of CCS and CCUS from the Ministry of Energy and Mineral Resources. Then we also expect numerous collaboration and partnerships, yeah, in order to get the green financings, soft loans, partnerships, in order to share the cost, project costs and benefit, sharing risks, and the technology capabilities. We are also expecting that there will be carbon trading program, and in terms of technology, we expect that the researcher will further improve and help us with the technology improvement and optimization in order to reduce capex and opex. And we expect that there will be carbon market, CCUS market, and the acceptance from the stakeholders. We believe that the CCUS will be economically viable with the technology transfer from developed countries to developing countries. And we expect that there will be sustainable finance in order to support the projects. Thank you very much, ladies and gentlemen. I look forward to listen to fruitful discussion from this afternoon sessions. Thank you.
Thank you, Dr. Oki, for your excellent presentation. I'll come back to you after we finish with our last presentation. I would now like to invite Mr. Dashak from the ASEAN Development Bank to share his perspective on how to developing countries speed up the CCUS implementation. Please take your time, Mr. Dashak.
Thank you so much, Dr. Saleh. Thank you so much, Dr. Saleh. Sorry, my video was not working. Yeah. Thank you so much, Dr. Saleh, for this opportunity. I would also like to take this opportunity to thank Ministry of Energy and Mineral Resources, Republic of Indonesia, and of course, ERIA for inviting us to this very important, interesting session. I've been associated with Indonesia for almost now 6 to 7 years, and I have been looking at how Indonesia has developed over a period of time. And while ADB continues to work with other developing countries, it is very important for us to review how Indonesia has worked so far, and would like to draw some conclusion as to what Indonesia has done and what Indonesia's experience and path can teach the other developing countries. One of the first things that comes to my mind is that Indonesia has been working on CCUS since almost early 2000, and so this is almost 20 years since Indonesia has been working towards CCUS. It has been developing and experiencing, gathering some more on the road understanding from other countries, and those things they have been doing continuously since early 2000. So that is one of the first thing. You have to learn from others and continue to work towards it without losing your patience. Second is, Indonesia has taken up some of the lowest hanging fruits which are available, so that the like say picking up Gundi field, which is on gas processing complex, and that is a low cost thing and something which will not face a big resistance when they go ahead and work further. Third thing, something that has been already told by my previous speakers, especially Tim Dixon and Mr. Juho Lipipion, that is to establish center of excellence, create a knowledge hub, support the government and policy makers, and work towards developing a very important workforce to create and implement and deploy CCUS in the future. So that is something that has been done very well by Indonesia. The Center of Excellence, which started say 4 to 5 years ago, has mushroomed into many other activities, and even while after ADB's initial support, they have been able to sustain many new areas of support and have worked quite independently. So this is a great experience that one needs to understand. The next, of course, is finding out what is the storage potential within Indonesia. So that continues to be a driver, something that is a long-term thing, but looking at the experts' opinion, whatever CO2 is being produced right now, out of that only 10% will be available for usage. Rest of it will have to be stored at some point of time. So storage identification within a country's premises is very, very important, and that is a no return deployment facility, and that is something that one has to invest and start working. So any developing country that is going to deploy or wishes to go ahead with CCUS will have to see that the storage resources are being explored and being deployed. Of course, and one more thing that one must compliment Indonesia towards as to what they have done with their CCUS portfolio so far, and how they have generated their resources and directed towards different streams where they need money. Indonesia has worked with ADB, Indonesia has worked with World Bank, they have worked with Japan, and each places they have tried to get a synergy. Of course, later on they have worked with private sector also, and tried to use these resources so that it can help them to reach their own ultimate goal by using say how Japan was using their monitoring technology, how Japan is using its carbon market, how what ADB intends to support, how World Bank's coal-based power plants projects can be reviewed. All those things they have tried to generalize it in a proper way so that a comprehensive picture emerges out of it. So one must congratulate Indonesia for using those resources very well. As far as ADB is concerned, of course, ADB will be more than happy to support Indonesia in its future endeavors within, of course, the framework of its new energy policy. And we can look forward to working with Indonesia, especially some of the important areas where ADB might be interested is common CO2 infrastructure. That is something ADB is very keen to see being progressed everywhere. And of course, the other thing is storage. These are the lowest hanging, these are the some of the two things wherein ADB will be having its eyes on, and probably can think of that at some later stage. Thank you so much. I think I'll stop here, and maybe we can talk later on as and when there is the flow. Thank you, Dr. Saleh.
Thank you very much, Mr. Dashak. Indeed, I think finance is the key elements of the CCUS project. So I think we always need to close to you, Mr. Dashak, to get your support on the finance. Thank you again for your excellent insight for our discussion. Now, if I may back to Pak Tim Dixon on your presentation, but you mentioned about 4 elements that need to be conducted by developing countries to implement this. One of which is sharing knowledge, Tim. I'm just curious, what is your idea when you see that we have many multinational companies in developing countries? how you think that we can strengthen our cooperation with them, because I believe that they also have their net zero emission target. They have all the experience on developing, CCS project in other countries. How you see that we can increase our collaboration with them to speed up the implementation of CCUS? Your time, Tim.
Okay, Dr. Sala, thank you very much for that very good question, which I've not had before. And it's a good question because you're absolutely right. These large oil and gas companies are multinational in themselves. And we know that they share learning between their own operations in different countries. They're very good models for that. And so I think working collaboratively with them in your country is a very good starting point. And also having the perspective that the geology is the country's own resource. So the oil and gas companies have got expertise that's very appropriate, but the actual resource that they're using is that of the country. And so I think having independent expertise as well to guide the interactions, such as from the Centre of Excellence, is very important, and working with these multinational countries as well. And we certainly see that ourselves as IAGHG. Half of our members are countries and half of our members are these multinational companies. And we act as a way of knowledge sharing between all of these, and it happens at our conferences and our events. And I think getting working groups together, getting expert networks together that involve both the multinational companies, the centres of excellence, universities and governments is a way of facilitating this sharing of knowledge from outside of bringing it out of the multinational companies, as you rightly suggested.
Thank you, Tim. Very valuable information and recommendation from you. I think that would be a good lesson learned for us, for developing countries to speed up the implementation. Thank you again, Tim. I would now like to move to Pak Sule and Pak Usman. We see that this Indonesian COE is getting more substantial in supporting all the technical and economical studies for CCS project in Indonesia. Could you please share the strategy that you do in strengthening the role of COE in Indonesia in accelerating the CCUS project, and what experience you can share with other countries in conducting all the studies and pilot project preparation, obstacles, collaboration, etc.? Can you share with us, Pak Sule and Pak Usman? Thank you.
Maybe I would like to answer first, and then it will be continued by Pak Usman. So, based on our experience, coordination issue is the most challenging. Normally we work alone. So basically, geologists work alone, petroleum engineering work alone. But in this CCS and CCUS issue, we have to work together. And together to make everyone in one desk to work together, it is not easy. So that's why it should be the first priority in order to move forward with our goal. And then later, what we have experienced also, that we have to work also with the other country experience. So based on in the past time, because we receive also support from Asian Development Bank during the initiation of the Center of Excellence, and then later we receive also funding from Japan related to the SATREPS project, and then we familiar to communicate with international people, and it will increase our capability. Okay, thank you.
Thank you, Pak Sule. Pak Usman?
Yes, I would like to add more Pak Sule explanation. The point is understanding the role of each stakeholder on this in all value chain of CCUS is very, very important. As we aware that CCUS, particularly in Indonesia, involving many agency, many sectoral. So understanding the role of this each of these agency or ministry is very crucial. During our activity in the Center of Excellence, coordinating with the other ministry, for example, with the Ministry of Environment, Ministry of Finance, and of course with research agency, has been carried out to complement all value chain needed to deploy the CCUS. Also, collaboration with, as Pa Saleh said, that private sector is also play a key role in acceleration of the CCS. As Pa Oki Murasa explained how Pertamina unlock the potential of CCUS. So Center of Excellence also getting close collaboration with the private sectors, but that has concern in developing of this technology in order to reduce their emission. That's all my experience, Pak Dr. Saleh.
Thank you, Pak Usman, for Professor Suli, for your for sharing the strategy that Indonesian CUE has been well established so far. I believe you are more than happy to share your experience with other countries. Thank you, Pak Suli, Pak Usman. Now I move to Pak Oki. Pak Oki, thank you for your excellent presentation. We understand that Pertamina is now conducting subsurface studies on some oil and gas field with the support of other countries, especially Japan. Any update of the progress and some good points to be shared with other developing countries? For instance, on the technical and cross-sectoral issues, if any? And what is Pertamina plan to collaborate with other emitters? For instance, power and industrial industries to develop CCS and cluster or hub. Your time, Pak Oki.
Thank you so much, Pak Dr. Saleh. Indeed, first about some progress to share. The economic efficiency of the project depend so much on the cost. Yeah. So first, the cost of the CO2 capture. As we know that the concentration of the CO2 determine most of the costs in the capture stage. So preferably in our first project, we use high concentrated CO2 with the concentration above 90%. So after typical acid gas removal is better, yeah. And then later we can also explore the typical CO2 with lower concentration from power generation. And then the next one is the transportation is very crucial, as we need to find the depleted reservoirs as close as possible to the CO2 source. And then the third one, the infrastructure or the existing infrastructure is very important in order to suppress the capital expenditure. The fourth one, if possible, we prioritize the CO2 enhancer recovery first before the storage, so we can get additional revenue from the oil sales. And the fifth one, the reliability is the key. So we need to study very well the geomechanics and the well integrity. About the plan to collaborate, we have the partners with the financial support, such as joint credit mechanisms, yeah, which is offered by our Japanese counterparts. As this CCUS is high capital expenditure projects, high capex projects in developing countries, the cost of energy is very crucial, yeah. So most of the time we cannot really pass the cost of CCUS to the customers. And then secondly, we have the collaboration with technology providers, as this is basically technology intensive. The third one, basically we expect to have collaboration with an objective for new business. For instance, CCUS as an enabler for blue hydrogen business. And finally, we try to collaborate with neighboring industries in such a way we can form a cluster or hubs which can suppress as well the capital expenditure. Thank you, Pak Saleh.
Thank you, Pa Oki, for sharing the activity of Pertamina. I believe that Pertamina will lead all the CCUS and carbon recycling project in Indonesia. Thank you again, Pa Oki. And I think we move now to Dr. Darshak. This is very important discussion on the finance. Could you please, Mr. Pak Darshak, to elaborate more in which area actually the ASEAN Development Bank is targeting or focusing to support CCS project? For instance, on technical support, regulatory development or project development, and how you can support us in attracting other source of funding to develop CCS, like for instance, like using the carbon credit or others. Thank you, Pak Darshak. Please, your time.
Thank you, Dr. Saleh. I would like to draw attention of this audience towards one specific new document, new thing that has come up, is the energy policy of ADB, which was published last September, which was approved by ADB board in last September. So there ADB has very specifically declared its support to CCUS as a technology which is going to be used for decarbonization in the future. Various CCUS related activities have been mentioned. One specific exception, of course, is enhanced oil recovery, which has been which has not been approved as an eligible project within ADB's pipeline. But ADB will be able to help and work with the Indonesia on CO2 storage, as I mentioned earlier, common CO2 infrastructure. It can also work on e-fuels, which is preparation of fuels out of CO2 capture. That is one of the things that may be interested. New business models development, that is one of the things that ADB can work with a developing country. So these are some of the major areas which can be looked into. As and when they come, it will be of course a case-to-case basis and depending upon the resources available at that point of time. Of course, to begin with, ADB can work on, as far as the regulations are concerned, of course, ADB was part of the initial regulation about 3 years ago, and an interministerial discussions, that is what was spearheaded along with the support of international consultants. That is what we had done. So these are the overall areas wherein ADB will be able to work, but more specific can only be discussed once some proposal comes, and depending upon when the proposal comes, what are the areas which ADB is, depending upon availability of resources, it can be seen on case-to-case basis.
Thank you, Pak Darshak, for your valuable information. I hope that more and more proposals will come to you from many developing countries to have or to ask support for the CCUS project in the future. Again, thank you, Pak Darshak, for your elaboration. Because of the time, I think I would like to thank all the speakers for all your excellent presentation, recommendation for developing countries to speed up the CCUS project in their countries. Again, I would like to thank all the organizing committee and the participants for following our session. With that, let we upload all the speakers. With that, I would like to conclude this session. Thank you very much for your attention. Ibu,
Thank you.
Ibu
Thank you,
Sri.
Bapak Saleh. Thank you, all the panelists. Give a round virtual applause to the panel too, everyone.
Thank you, thank you.
Terima kasih, Bapak. Ladies and gentlemen, we are now in the last agenda of the workshop. Last but not least, to close the workshop, allow me to invite Mr. Koji Hajiyama, Chief Operating Officer of Area, to deliver a closing remark. Please.
Okay. Thank you for introduction. Dr. Yudo Dwinanda Priyadi, Chairman of Energy Transition Working Group, G20 2022. Distinguished speakers, panelists, moderators, participants, ladies and gentlemen, a very good afternoon. It's great honor to make the closing remarks in this event. First and foremost, I'm very grateful with the outcome of today's conference of the G20's Energy Transition Working Group side event, focusing on making CCUS affordable. We are able to concisely take stock the current development of CCUS cutting-edge technology innovation, various policy instruments, and government to ensure that the technology will be scalable, affordable, and cost competitive in the near future, with the aim of commercial deployment in 2030 onwards. Ladies and gentlemen, today, conference has brought a big success, which is one of the stepping stones toward making CCUS affordable in the region, as we have gathered many big-minded people working in the frontier of CCUS development and deployment. We also learned that there are multiple pathways to carbon neutrality and net zero energy system. Besides the broad suite of technologies, the carbon capture, utilization, and storage CCUS is one of the least cost pathway to net zero emissions. The CCUS has been gathering momentum globally in response to rising climate ambitions and actions. Most notably, in 2021, the commencement and the deployment of the first CCS facility also gets started in a number of new countries, including Indonesia and Malaysia. We have also seen the first application of CCS to liquefaction of natural gas, the first commercial direct air capture with storage business announced in Europe, and the construction of world's first commercial application of CCUS to cement production. Within East Asia region, Japan makes its best efforts to develop the technology of CCS project through practical demonstration, such as Tomakomai project. Regarding this project, I was in charge of this project when I worked in the government of Japan. And I also had visited there. So I'm personally very pleased to hear the good progress of Tomakomai project. The development of value chain networks of CCUS, including the development of CCUS hubs, namely the industrial centers that make use of the shared CO2 transport and the storage infrastructure, could help accelerate deployment of CCUS by reducing cost. The issue of affordability is complex, as there are so many different applications to carbon capture depending on source of CO2, with the cost from $30 per ton CO2 in gas processing, such as ethanol production or natural gas processing, to over $102 per ton CO2 in coal-fired power plants, steel and cement production. So deploying CCUS is already now a relevant option for many processes. In this regard, the government have a critical role to play through policies that establish a sustainable and viable market for CCUS. But industry must also embrace the opportunity, while technology innovation will need to draw down cost further with the scalability and the economic of scales. In addition, the international cooperation via G20 and other platforms such as CM, Asia CCUS Network, and other platforms can play a vital role in ensuring that the key players such as government, public, and private entities, industries, research institute and academia, and banking institution can learn from past experience, gaining from good practice and avoiding earlier mistakes in the most important to accelerate the CCUS deployment and make the technology affordable. Finally, capacity building and knowledge sharing on CCUS are so critical to help policymakers to understand the element of the suite of CCUS technologies and the required policies that are best fit into each country's circumstance. The speed and adaptation of CCUS technology to address the global climate goals will require fast learning through CCUS capacity building. Effectively, policy including putting in place clear and supportable legal and regulatory frameworks, creating business model, and facilitating CO2 infrastructure investments. Ladies and gentlemen, last but not least, I would like to take this opportunity to tremendously thank the Ministry of Energy and Mineral Resources of Indonesia for co-hosting this event with the area. I also thank Dr. Yudo Dwinanda Priyadi, Chairman of the Energy Transition Working Group of G20, and his team for excellent leadership and arrangement. And a great appreciation and thanks to speakers and panelists who have shared their invaluable insights. Let me stop here and I wish you a wonderful day. Thank you very much. And back to MC. Thank you.
Thank you, sir. Thank you very much. Honorable Chair of Energy Transition Working Group, keynote speakers, moderators and panelists, representative of G20 members, and everyone that could not be mentioned one by one. On behalf of the Direktorat Jenderal of Oil and Gas, of the Ministry of Energy and Mineral Resources of Indonesia and area as the co-organizer, we would like to deliver our bunch of thanks for joining us today. See you in another G20 side event series. Stay safe, stay healthy. Thank you, everyone. Bye-bye.
Terima kasih semua. Thank you for all.